In section 3.2, we focus on degree 2 polynomials, sometimes called quadratic polynomials. And so in terms of polynomials, we expect a degree 2 polynomial to look sort of like this. Oh, that's a bad color. Something like this, where we have a term with an x squared, a term with an x, and a constant term possibly. And when something's written like that, a quadratic's written like that, we call that the general form of the quadratic. But we're going to start off by looking at a different form a quadratic can take, and that is the form that we call vertex form, which looks like this. And so in this form, the x is still the variable, and the letters h and k in this form are describing to us where the vertex of the parabola is. The vertex of a parabola is the single turning point that the graph of the quadratic has. So every quadratic has one turning point, and that turning point will be called the vertex. So, for example, if we're trying to plot the quadratic that's given by f of x equals x minus 2 squared minus 4, the vertex is at the point 2 comma negative 4. Now, sometimes people have a hard time remembering this formula, this form, because one of these numbers is subtracted and one of them is added. So back up here, one of these is subtracted and one of them is added. And so sometimes it's a challenge to remember which one's which. But here's a quick way to remember that. What you're trying to do from vertex form is think about what x makes this stuff equal to 0. So in the vertex form, there's always some stuff that's inside of the parentheses that's being squared. And so you're asking yourself, what x makes that 0? So we can see from this, in this problem, that the number that makes that, say, 0 squared is x equals 2. And so that tells us the first coordinate of our vertex. And of course, anytime we have the first coordinate of a function, the second coordinate is always just found by plugging the first coordinate into the formula for the function. And so f of 2 should be 2 minus 2 squared minus 4, or 0 minus 4, which is negative 4. So even if we completely forget which thing is minus and which thing is plus, if you can remember that you're trying to make the stuff inside the parentheses equal to 0, then you'll figure out where your vertex is. So on the graph, the point 2, negative 4 is down here. And so that's the turning point. So we know the graph is going to turn there from going down to going up. And so that's a lot to know. So if we plot any other point, we'll be able to get a pretty good idea of what this looks like. A very typical other point to plot would be the y-intercept, because the y-intercept comes from plugging 0 in for x in the formula. And usually 0 is a fairly easy number to plug in. So if you do the arithmetic here, you'll find that f of 0 is equal to 0. So we know that the intercept, the vertical intercept of this graph is there. And so that gives us a pretty good idea of how this looks. We know the blue point is the turning point of going where the graph goes from going down to starts going up. And we have a particular point that we know we need to hit. There's one more piece of information that we have about quadratics, and that is that they're symmetric about their center, where the center is defined by this turning point. So this dashed line is not meant to be part of the graph. It's just to show the axis here that goes through the vertex. Our parabolas are always symmetric about this line. And so immediately from the fact that this point 0, 0 is on the curve, we can immediately say, well, the symmetric point over here, 4 comma 0, also would be on the curve. So we're thinking of that red point as being a mirror image of the black point if you think of the mirror as being the dashed green line. So let me get rid of that green line because I don't want you to think that's part of the graph. It's really just a visual idea to think about the symmetry, and then we can draw the picture of our parabola. It'll be this bowl-shaped thing that comes down. It's supposed to go through the black point. It'll turn at the blue point and go back up like that. So that'll be a graph of our picture. So let's try it again with another one. You see in this case there's a number out in front of that, and that's perfectly fine. And the fact that there's a negative number will have an impact on what we get here. But we're going to start by looking at the stuff in the parentheses and asking ourselves when that term, when that expression that I've shaded red is equal to zero. Is equal to zero. Whatever value of x makes that zero, that's the first coordinate of our vertex, and we're off and running. So why don't you pause the video and see if you can fill in the where the vertex is and maybe plot the y-intercept, and I'll do the same thing, and the video will pick up again with all that stuff added. All right, so I filled in this material, that filled in the information that's the same as the previous one. My vertex is at 2 minus 3, that's the red point, and my y-intercept is 0 minus 5, which is the blue point. And so we have this odd behavior where the turning point is actually up above the other point. And so that's telling us that this parabola is going to go up and then turn over to come back down. We do get an extra phantom point here, just like we did before. The symmetric point to the blue point would be over here. Again, think about the axis of symmetry going through the vertex and where the mirror image of the blue point would be. And you'll see that. And so the parabola comes down like that. So you can see that these parabolas can open upward. We would say this is cupped upward, thinking of that as something that like maybe a cup that holds water, and that's the upward direction where it would hold the water. And this is cupped down. But it can be either way. It can be open, the opening can be wide or thin. It can be located anywhere, and the cup could go up or down. But they all will have the same basic shape. So there are 2 more problems at the bottom of this page. I would recommend you pause the video and see if you can sketch the vertex and intercepts for each of them, and then draw a little sketch. And I will count to 3, and I'll add the solutions to all of these.